Hello guys, this is Math Boy. I am back with my topic to prove root 2 as an irrational. Now in this question we have to prove that root 2 is an irrational. So first step, assume root 2 as an rational number. Assume root 2 as a rational number. Root 2 is equal to p by q. Now first I assume that root 2 as a rational number. If we assume root 2 as a rational number, we can write it in the form of p by q. So I have written root 2 is equal to p by q because we have assumed that it is a rational number. So here p and q are integers. P and q are integers and co-prime numbers. Here P and Q are integers and co-prime numbers. Now root 2 is equal to P by Q. I will take this, I will transpose this Q to LHS side. It becomes root 2Q is equal to P. Now it's root 2 is equal to P. Now I will do, and I will square on the both sides means, I will square on the both side means squaring on both sides means root 2q whole square is equal to p square. Squaring on both sides means on the LHS side I will square, and on the RHS side I will square. It becomes root 2q whole square is equal to p square. Now I will separate root 2 whole square q square is equal to p square. Now here a square and root get cancelled, so it becomes 2q square is equal to p square. Now it becomes 2q square is equal to p square. Now I will take this 2 to RHS side. Here it's multiplication sign. If multiplication goes to RHS side, it becomes division. So it becomes q square is equal to p square by 2. Now it has become q square is equal to p square by 2 because I have taken 2 to RHS side. Into becomes division, plus becomes minus, minus becomes plus. So now we have to write the theorem. If 2 divides p square, it divides p also. Now I have written q square is equal to p square by 2. Here if 2 divides p square, if 2 divides p square, it divides p also. So I return the same. If 2 divides p square, it divides p also. Now I will assume p square as 2c. I will take this as my first equation. Now I will assume p square as 2c. So q square is equal to replace by 1. Now I will take this first equation here. Q square is equal to, I will write here 2c 2c whole square by 2 because I have assumed here p square as 2c. So 2c whole square becomes 4c square by 2. Now 2 ones are 2 2's a cancellation. So q square is equal to 2c square. I have did here cancellation. So 2 ones are 2 2's are 4. So it becomes q square is equal to 2c square. Now I will take this c square to the LHS side. C square is equal to q square by 2. I have taken q square to RHS. I have transposed. So c square is equal to q square by 2. Now we have to write the theorem. If 2 divides if 2 divides q square, it divides q also. Now same, if 2 divides q square, it divides q also. If 2 divides q square, it divides q also. Hence our assumption is wrong, which we have assumed. Hence root 2 is irrational. It is a big process we have to do. Same, if they ask to prove any no any any number as irrational. Thank you.